Hello, welcome. Today, we're going to create a calculator in assembly language. So, let's do it. So, before we start, here are some goals that we want to achieve in this project. First, we want to create a, yes, you guessed it, a functional working calculator. We also want to make sure that the program checks the inputs of the user so that everything is valid. If the program asks for a number, the user should give a number. If the program asks for a symbol, the user should give a symbol. And lastly, we want to have a nice, presentable, graphical user interface. So without further ado, let's get started. Okay, so we'll be using DOSBox for this tutorial. Now first, all we gotta do is load up our C drive onto DOSBox. And then, we're gonna change directory where the file is located. And then we're gonna do some stuff that you have to do, such as setting the path for the TASM, which is a necessity in DOSBox. And then we're gonna type TASM project, and then T-Link project. And once we clear the screen, we are good to go. Okay, let's try adding some numbers. Let's try 1 plus 1. And there we go, became 2. Let's try 9 plus 9. 18, that's correct. One more. 5 plus 5. 10. So, it works. And also one more. 4 plus 9, which is 13. Alright, so this works. Now let's subtract some numbers. Let's try 1 minus 1. 0. Let's try another one. Let's try 9 minus 5, which is 4, and that's correct. How about negative numbers? Does it work? Let's try 1 minus 9. And yes, we get negative numbers. And lastly, let's try 1 minus 8. And yes, negative 7. And 5 minus 6 is negative 1. Let's try 8 divided by 8, which is 1. Yes, our quotient is 1 and remainder is 0. 4 divided by 2. Yes, quotient of 2 and remainder of 0. This is also correct. 3 divided by 2, because 2 goes into 3 one times and we are left with the remainder. 7 divided by 2. And yes, 2 goes into 7 3 times, but leaves a remainder of 1. Now how about 0 divided by 0? Let's try that. And yes, 0 divided by 0 is undefined. Let's try some multiplication. 1 times 1 is obviously 1. This is correct. 9 times 9 is, yes, 81. 5 times 6 is 30. And 0 times 0 is obviously 0. And multiplying a number by 1 will always be its number. So 1 times 9 is 9. Okay, so the first thing we're gonna do is check that the user can only input what the program is asking for. A, S, nope, doesn't work. So we can only input digits or integers. So let's do that. And same for operand 2. There we go. Now for operator, obviously it's asking for a plus, minus, multiplication, or division, and only those symbols work. And once you do that, it works. And lastly, for the continue, y/n, we want to make sure that the user only inputs a capital Y or small case y, and also for the n. If it doesn't, it won't work. Alright, so let's have a look at the source code. So I'll be using VC Code to actually read through the code. So, the first part of the code is the model medium. This is basically quintessential part of the program. You need to do this every single time you create a program in assembly language. And then all we gotta do is create some predefined strings that ask the user to enter the operands and the operator. And then we're gonna make sure that we have predefined strings to tell the user that we successfully executed the program. And then we also have a predefined string for the continue y/n. Now all we gotta do is set some global variables for the program to work and put some design as well. These are just codes to make the program more pretty. Now the first thing we're gonna do is jump to screen. And screen is basically the long code that shows that wonderful, beautiful background. And yes, it's not exactly pretty on the code, but as you can see, it gets the job done. So here are a bunch of cursor offsets that help create the boxes, the colors, the shapes, the presentable graphical user interface. Once we reach the end, we jump back to loop 1. And what loop 1 does is it basically goes to operand number 1. Now that we're operand 1, we can ask the user to input any number. And obviously, we're gonna have to check for that. And we input the number and we convert it to hex. And once we compare the number, we check if the first number failed, and if it does fail, it's going to loop back. And this is how we can make sure that the user only inputs numbers. But if the user does put the correct input, we can jump to second operand. And this works exactly the same as loop 2. We do the exact same thing for the second operand. And then we choose the operator for the operation, and we do a similar thing with operand 1 and operand 2, but we only have 4 choices: multiply, divide, add, or subtract. And then once again, we make sure that the user only inputs what the program is asking for along those 4 symbols. And if not, it's going to jump back to operator loop, and it's going to repeat everything again. So let's go through the main codes. In multiply, all we gotta do is pop the stack 2 times to get the 2 numbers that the user inputted. And once we do that, we're going to multiply it. But first, we need to convert the number into hexadecimal by subtracting 30 from it. Then we push it onto the stack, and then we perform our operation. We need to display the numbers separately, so we isolate each number and put it on the stack, and then we can show it. Now addition isn't that straightforward, but we do the same thing. We pop the stack twice to get the values that the user inputted. We add them, and we display them. It's generally very simple. For subtraction, we do the exact same thing that we did in the first 2 operations. We pop the stack twice, and then we first check if we get a negative value, and that is by comparing the first 2 numbers that were inputted by the user. So once it happens, we jump to the negative loop. We basically do a swap in the data storage, and then we solve it for the program to know that we are dealing with a negative number. Then we solve it by simply subtracting it, and then once we do that, we're going to check if the number is negative, and we jump down to symbol where we can print out the negative symbol on the number. Then we can display the number. But if it is not a negative number, meaning that the operand 2 is less than operand 1, we just jump directly to solve. And once it does that, it bypasses the jump to symbol, and we just go directly into show. Division. Now, this is relatively the same. We pop the stack twice, but we check first if operand 2 is 0. And if it is 0, then we know that it is 0. Anything divided by 0 is 0. And 0 divided by 0 is undefined, so we gotta check that first. But if not, we get the first number, and we convert actually both numbers to hex, just like the previous operations. Then we divide it. Then what we're gonna do is display the answer. But instead of displaying the answer, we're gonna first display the quotient, and we're also gonna display the remainder, so we can show the user where all the values went. And once that's done, well, we're done. Now for the last part, we're going to ask the user if they want to try everything again. And it's very simple, just like the first and second operand. All we do is ask for user input. We're gonna make sure that they only press one of 2 choices, yes or no. If the user decides that they want to continue, we're gonna loop back all the way to screen, which is basically going to render the background and operand 1 again, all the way from the start. But if the user does not choose to continue and they just want to leave and exit, well, we're gonna terminate the program. And that's it. Now that right there is a calculator in assembly language. And hopefully I explained everything as thoroughly as possible. If you have any questions, don't forget to comment, like, and subscribe. And hopefully we can make more of these videos. That's it. Thanks for watching. Have a good day.